We are talking about distributed power, power that's produced on the customer side of the meter. And the one you are probably the most familiar with is the solar panel. And in fact, most people, when they think about green buildings, the first thing they think of is, oh, solar panels. So solar panels are items that are made out of semiconductor material, and they're designed so that they convert energy from the sun to electricity. They use a photoelectric material, which means when the material is hit by solar radiation, electrons are ejected. And the photovoltaic effect causes voltage to build up when solar radiation hits these things. And you know about voltage. A difference in voltage produces current. Here's just a brief timeline. Solar cells were used in satellites many decades ago. Another historical idea. I don't know if you know that Albert Einstein did not win the Nobel Prize for his work with the theory of relativity. He actually won the Nobel Prize in 1921 for his discovery of the photoelectric effect. His discovery had to do with light, that it travels in both waves and particles, and that if you hit it with energy from the sun, electrons will be knocked loose and you'll get current. So this solar radiation knocks electrons loose, and the electrons move from atom to atom, and so there's a negative charge that's moving. But when an electron leaves its atom, it leaves a hole, it leaves a blank where there should be an electron and now there's not. And so that atom is slightly positive. And as you look at these things, if you could look at them through some kind of special microscope, you'd see that the electrons, the negative charges are moving along, but also the holes are moving along. It is as if the holes carry electricity, but it's positive current, and the electrons carry electricity, but it's negative current. So manipulating these two kinds of phenomena, holes that are positive, where electrons should be, and extra electrons that are negative, manipulating those two lets us make semiconductor devices that produce current. And you might remember, I think we talked briefly about conductors that conduct electricity and insulators that cannot conduct electricity. The semiconductor is in between there. It has 4 electrons in its valence shell, and it's not a good conductor, it's not a good insulator, but sometimes if you add a little bit of contaminant to it, you can get extra electrons or extra holes. And that's how these things are made. In fact, it's the same way computer chips are made. The silicon material is put into a furnace with some contaminating gas, and it might be boron and it might be germanium, and there are some other kinds. If the gas has just a few extra electrons, this silicon will come out negative. If this contaminating gas has just a few more holes than normal, this silicon will come out positive, or p-type. And so you put the n-type and p-type, the negative and the positive, together, and you get a junction. And at that junction, that's where stuff happens. Voltage causes current to flow. If you were to make a drawing, a schematic, here's the symbol that you would use for a solar photovoltaic cell. We say PV for short because it's faster, but it stands for photovoltaic. And these photovoltaic cells are made with the same process that computer chips are made, using the same chemicals. Here's a look inside Solar World, which is no longer there. It was a solar cell plant up in Portland. So it uses the same process as computer chips. It's just that the clean room, while really clean, is not as clean as computer chips. So for a while we were hoping that vacant computer chip plant in Eugene, Oregon would get bought by a solar panel manufacturer, but I think it did not. So each one of these cells, made of silicon, produces about 0.5 volt of electricity, and we need more than that. So we wire them together in series, and when they're in series, we can add up the volts and get more volts. So we connect several cells together. That makes a module. We connect several modules together. That makes a panel. And we can connect several panels together in some mounting hardware, and that makes an array. And they can be those flat glass-like silicon things. They are also available as thin film. You can have them as roofing, and you can have them as part of your windows. Here is the Lillis Business Center at the U of O that you've looked at before. I think we looked at it when we talked about daylighting. This whole front glass wall is covered with solar PV cells. So you got your panels with your solar cells in them. Now you need some other things. Unlike other kinds of power generation, solar PV cells produce direct current, DC. They do not produce AC. So you need a device called an inverter to change that DC to AC so that you can use it in your house with all your AC light bulbs and toasters and things. Then there's a power conditioning unit that keeps things working well. And if you're not connected to the grid, you might need batteries. If you are connected to the grid, life is relatively simple. The grid is the storage device. So sometimes the sun is shining and sometimes it's not. And if you're producing more electricity than you need, net metering lets you sell that surplus to the grid. If you're producing less electricity than you need, then being connected to the grid lets you just take power this way through the meter. If you're doing a standalone system, but you're not connected to the grid, designing this system is more complex. And one of the things that you're going to need is batteries to store this power, like the grid does. Batteries last a long time. They don't last forever. They last some years. So there is a cost of maintaining and replacing those batteries over time. We've talked about net metering. This is what lets you use the grid as your storage facility. So, the cost. The cost of generating electricity with these PV cells, generating it is free, sunlight is free, buying the setup is not free, but these are becoming so much more common nowadays that the cost is falling rapidly. Here's a table about calculating the payback period. So when you're thinking about renewable energy, you think about not just what is the initial price of the thing, but how long will it take me to get back my cost that I invested. So if you're doing some kind of system where your payback period is 2 years, well, heck, that's a no-brainer. Of course you're going to do that system. If you're doing a system where, and I can't think of an example, maybe you're building a nuclear plant, which is not renewable, but never mind that. You're building a nuclear plant and your payback period is 35 years. Well, that's a long time to keep your money tied up. So what energy analysts do is they evaluate how long will it take me to recoup my original cost, and now everything after that payback point is going to be revenue. One of the advantages of these things is that they don't emit pollution. They don't emit toxic chemicals, and they don't emit greenhouse gas pollution. Another advantage is if you don't need to be connected to the grid, you can use them in all kinds of places. Out in the country, you can generate your own power. You see them, here's a parking meter in Portland. You see them all over the place, around Eugene too. Many of them generate power for traffic signals, pedestrian signals. So those are good. The disadvantage, though, is the manufacturing of the thing. And one thing you will notice about renewable energy is there are always trade-offs. One of the fundamental rules of sustainability is there are no free lunches. So, there are no free lunches, there are always trade-offs, and you just have to balance those out as you're making your decisions. One disadvantage of solar cells is that they use a lot of chemicals in their manufacture. Think about the chemicals, sulfur, I can't remember, all the chemicals that are used in manufacturing computer chips, sulfur fluoroxide or something like that, and lots of them going through these pipes. We use those making solar cells, so that's a negative. The manufacturing plants also use a great deal of energy to make these cells, so you have to weigh those costs. Now, there are a couple of other things, devices, related to solar that are not solar photovoltaic. So we want to make sure we keep these straight in our minds. Solar water heaters and solar thermal or concentrating solar power generation. So solar thermal we looked at when we talked about water. This is how we heat water, or at least preheat water, using panels on our roof or evacuated tube collectors. Concentrating solar, we're going to talk about this next time. Concentrating solar uses heat to heat up liquid really hot to generate steam to turn a turbine to turn a generator. So concentrating solar uses heat from the sun to turn a generator. That's totally different from a solar photovoltaic cell, or PV.